and good afternoon across the locations where you all are present. Okay, so today we will solve one question of mensuration where the question is given like this: a hemispherical bowl, hemispherical bowl is given whose internal diameter is 36 centimeter, which contains a liquid, and that liquid which is filled into that hemispherical bowl is this liquid is to be filled in cylindrical bottles of radius this 3 centimeter, height 6 centimeter. How many bottles are required to be filled by this bowl? Okay, that means we need to find how many bottles are required to empty the bowl, so that all the bowl will be emptied, all the ball, the liquid of all the ball is emptied, then this liquid will fill in how many such bottles. Okay, so this is a bowl, a hemispherical bowl is will look like this, right? This is containing some liquid inside it. This is containing some liquid. Okay, now this is transferred into bottles. This is transferred into bottles. So the bottles are in the shape of cylinder. So let's say this is a cylinder, another bottle, because in one bottle the volume of this bottle is not always equal to this volume of bowl. So it may be required that we will be using n number of bottles or x number of bottles to empty the complete liquid of this bowl. So this we need to understand. And what is the number of such bottles that need to be calculated, right? So let such bottles are, the count of such cylindrical bottles are x. So I am just mentioning, let x bottles in the shape of cylinder. Okay, let x bottles are required to empty the liquid of this bowl, right? So let x bottles are required. Now when these x bottles will be required, what is the concept? Because the liquid containing in this bowl will be the same as the volume of this bowl, right? And this is an hemisphere. So it's simple, very simple. The volume of this hemisphere, that is 2 by 3 pi r cube. 2 by 3 pi r cube is the volume of this hemisphere. So this volume will be contained into this bowl, right? And this we are just pouring it into this cylinder, and the remaining just go to the second cylinder and just pour it into this. Now the leftover just go into this. In this way, suppose we will be consuming x such cylinders, right? So we can say that 2 by 3 pi r cube, that is the volume of this liquid inside this ball, will be equal to x times, that is x is the number of cylindrical bottles. You can see the question, number of cylindrical bottles, let's say it's 8. So this x times this bottle, that means x into the volume of this cylinder, that is pi r square h, right? Pi r square h is the volume of this cylinder. So we can just I'm just mentioning it over here. R, small r and small h are the dimension of cylindrical bottle. Cylindrical bottle. So this is cylinder, and this is the dimension. Capital R is for hemispherical ball. Hemisphere. Right? Now just put up the values and get the value of x. So we can say that number of bottles will be required to fill up the entire liquid of this bowl into these cylinders, right? So 2 by 3 pi r cube, 2 by 3 times pi, what is r? You can see here a hemispherical ball with internal diameter 36 centimeter. So 36 centimeter is the diameter of this ball, you can see. So what will be the radius? The radius of the ball will be 36 by 2, because diameter will be divided by 2 to get the radius. So this will be the radius and it will be q. This is equal to x times, so I am putting x here into the RHS, times pi r square h. What is pi r square h? Just put up those values. Keep pi as it is into r square. What is r square? R and h are the dimension of this cylindrical bottle. You can see here radius is 3 centimeter and height is 6 centimeter. So put up the value of r over here as 3. So is the 3 square will be radius square into height will be 6, right? So just solve this to get the value of x, right? Here you can see pi and pi will be cancelled out, right? Now we can see what is the value of x. Keep x into the RHS and into the LHS we are having 2 by 3 into 36 by 2 whole cube, and this is 3 square, that will be coming into denominator, and 6. This is also coming into the denominator of LHS, right? So solve this. This is a very simple arithmetic calculation, right? Sorry. So this will be coming as 2 by 3 into, this will be cancelled out to 1836. So this will be 18 into 18 into 18 into the numerator divided by 3 square. 3 into 3, 9 into 6, right? Equal to x, right? Now this 6, 3 times 18, 9, 2 times 18, 3, 6 times 18. So we get the value of x as how many bottles will be required, how many such cylindrical bottles will be required. Such cylindrical bottles will be the value of x. What is the value of x? It is 2 into 6 into 2 into 3, right? So this will be coming as 12 into 6, which will be coming as 72. So we can say that 72 such cylindrical bottles will be required, which will empty the entire liquid of this bowl, right? 72 bottles. So 72 cylindrical bottles will be required. So this is our answer, right? So in mensuration, what is the question which we have taken from volume? That a hemispherical bowl of internal dia 36 centimeter contains a liquid. This liquid is to be filled in cylindrical bottles of radius 3 centimeter and height 6 centimeter. We need to find the number of such bottles where the required liquid of the bowl can be emptied, right? So here we have taken this bowl. We know the volume of a bowl or the shape of a bowl is hemisphere. We know the hemisphere contains liquid. So the liquid containing inside a hemispherical bowl is the volume of that hemisphere. So that is equal to 2 by 3 pi r cube, right? And this will be equal to x times pi r square h. Why? Because this liquid is to be emptied into number of cylindrical bottles, and let us assume the number of such cylindrical bottles as x. Now, so x times the volume of this cylindrical bottle, that is pi r square h, right? where a small r and a small h are the dimensions of the cylindrical bottle and capital R is the dimension of the bowl's hemispherical bowl. So it's given that ball with 36 centimeter diameter. So radius of the bowl will be 36 by 2. Just put up the value over here and equate with the RHS, that is x into pi r square h, where r square and h, small r and small h are the parameters or the values of the cylindrical bottle, right? Now just put up the value over here to get the value of x. Now x is calculated as 72. So we can say that 72 cylindrical bottles will be required where the volume of where the liquid which is kept inside the hemispherical ball can be emptied. So we can say that x number of bottles, that is 72 such cylindrical bottles will be required where the entire volume of the hemispherical ball can be emptied, right? So this is our answer. So for volume and surface areas of or all such questions of mensuration, we will use the concept based upon the understanding of the question. Okay, so here the liquid is mentioned, so that's why we can easily imagine that when the liquid is mentioned, then definitely this will a liquid acquires the shape of the container, right? So the container is hemispherical bowl, and you know that a liquid when it occupies the shapes of the container, that means this will be the equal to the capacity of the hemisphere, right? So just put up the value, that is the volume of the hemisphere. We know that 2 by 3 pi r cube. So 2 by 3 pi r cube is the volume of the hemisphere, right? So put up the value, because we know that the radius of the hemispherical ball is not given, it's given as diameter. So we know that diameter will be double of radius. So 36 by 2 is the value of the radius of this ball. Just put up the value over here and equate and just find out the value of x, right? What is x? X is the number of such cylindrical bottles where the entire liquid can be emptied. Okay, so just I mentioned it by arrow so that you can easily understand that this liquid can be transferred into these x number of such cylindrical bottles, so that the entire volume of the hemispherical ball, that is entire liquid volume, will be equal to the liquid containing into these cylinders, right? So in this way we just calculate the value of x as 72. So 72 such cylindrical bottles will be required. 72 such cylindrical bottles will be required which can empty the entire liquid of this hemispherical ball, right? I hope you understand. Yeah, hello, I am dumb cat. Okay, please, you can put up your queries into the chat box if this is understandable to you. Only two things we need to keep into mind. What? That the area of hemisphere, you should know it, that is 2 by 3 pi r cube. And what is the area of a cylinder? That is pi r square h. And how many such cylindrical bottles will be required? You can know, you just know that number of cylinders is repeating. So let us say n, repeated addition is multiplication, right? So x number of such bottles. So x times such volume, pi r square h. So x into pi r square h. Just put up the value to get the value of x as 72. So this is our answer, right? I hope this question is very much clear to you. For any queries, you can put up into the comment box. Hello, dumb cat. Yeah, I'm not getting your question. Can you elaborate more detail? What's your query is? Yes. Let me know. Yeah. So this is a very simple question of mensuration, where we have taken or just used the concept of volume. Okay, the two things which we need to remember: the volume of a hemisphere, that is 2 by 3 pi r cube, volume of a cylindrical bottle or anything which is in the shape of a cylinder will be pi r square h, right? Just put up the values over here to get our answer. So you can just, I am going through the questions very quickly over here. A hemispherical ball of internal diameter 36 centimeter contains a liquid. This liquid is to be filled in cylindrical bottles of radius this and height this. How many bottles are required to be filled in by this liquid liquid containing into this ball? Now, let us assume that such number of cylindrical bottles will be X, right? You know that liquid which will be poured into this hemispherical ball will acquire the volume of this hemispherical ball. So, right? So, just apply this thought and we can understand the liquid will carry the volume, right? So, that's why we consider the volume of this hemispherical ball as 2 by 3 pi r cube. Hi, Jay Lilran. Yeah. This is class 9 mensuration question. Perfectly right. I am fine, Jay. Thank you so much for watching. So today I am just sharing this concept of a mensuration. Okay, a simple volume question where a hemispherical ball of internal diameter is given, whose dimension is given, which is to be fulfilled or emptied into n number of cylindrical bottles. We need to find out how many such cylindrical bottles will be used to empty the liquid of this hemispherical ball. I am fine, Jay Lilran. Thank you so much for asking. Hope you are also doing good. Yeah. Sorry. So, what I want to make you understand that a liquid is poured inside the hemispherical ball. So, we need to understand the liquid will acquire the shape of the container. That's why I use the concept of volume of this hemispherical ball, right? Now, the volume, this need to be emptied into number of cylinders, right? So, this will be 2 by 3 pi r cube. 2 by 3 pi r cube will be the volume of the liquid contained inside this hemispherical ball, right? And this liquid need to be emptied into these multiple cylinders. We need to find how many such cylinders will be required. So let us assume this as X. We have assumed let X bottles are required, right? Now this liquid when poured into cylinder, that liquid will occupy the volume of this cylinder, isn't it? This will occupy the volume of this cylinder, right? Similarly here. So same thing is repeating. This question of NCRT. So you will get such questions into NCRT also, but with different different dimensions it can be. Okay, Children, actually I want to make all understand how such questions, it can be in place of hemisphere, it can be a cylinder, and here you can have hemispherical balls into the right hand side, right? Here you can have a conical flask, like so you should note the what is the volume of a cone, that is 1 by 3 pi r square h. So just put up the value of 1 by 3 pi r square h over here, right? It can be a sphere, 4 by 3 pi r cube. Yeah. So you should just remember the volume, what is the formula of the volume of each of the geometrical shapes, right? And just apply this concept. What? Volume of the container which need to be emptied, kept over here into the LHS. Volume of the container which is where the liquid need to be emptied, need to be kept into the RHS, right? And this will be, let us assume X number of such cylinders will be used, cylindrical bottles. I put up the value where a small r and a small h are the cylindrical bottle parameters, dimensions, and capital R is the dimension of this hemisphere, right? Yeah, children, give 1 minute please. I am just closing this question and then we are coming to you. Thanks for understanding. So just put up the value. We know that hemispherical ball's radius is not given, its diameter is given as 36. So we have calculated 36 by 2 as the radius, and just putting up the value of 3 and 6 as the radius and height of the cylindrical bottle, and we get the value of X, right? So X, that is 72 number of such cylindrical bottles will be required where the volume of the entire hemispherical ball liquid will be emptied on, right? So this is our answer. Yeah, children. Oh, your message. Okay, I did. Yes, yes. You can put up your question. I think you have deleted your message. You can put it. No, it can be of NCRT. ओके, साइंस भी सर जी, साइंस भी पढ़ाया करो प्लीज। ओके जय, थैंक यू सो मच, थैंक यू सो मच। You can refer one shorts where I have put into my channel today. Okay, that is of science only. It's from momentum. Okay, a train with some weight of the engine and bogies are given and according. So yeah, I will come up with this physics chapter. I committed to you for the displacement and distance, possibly for next time for sure. Okay. uh, Actually, I'm getting some sort of time due to some other engagements, so that's why I'm not able to come to you. But Jalilan, this is my commitment to you, so don't worry. I will not get you disheartened. Right? Yeah, you are right. This is concept of force and laws of motion. Perfectly right. Conservation of momentum. Yeah, second law. Yes, yes. So I will come to that also. Okay, but I got your point and point taken, Jay. I will just come to you with the physics topics for the next live session. Okay, for sure. Even I have committed to you for the distance and displacement topic also. So for the distance and displacement, I will keep a separate live session because that requires a broad understanding and it can be of even 30 minutes is not enough. So we will make it into one or two sessions, right? Sure, Jay. Thank you so much for understanding and giving me some time. Thank you so much. I want to have some interactive study. Okay. If you want to understand, just put up your queries. I am always there to understand. So for all volume related questions, I think you get the concept, right? The volume of a container is just obtained by that liquid which is poured into that container, right? So just apply that concept. You should remember the volume of the container and just equate with n number of the containers where it need to be refilled or emptied, and you just get the value of that x. Okay, in place of cylinder it can be conical flask, here it can be a sphere, here it can be cylinder, and here it can be a hemisphere. So it can be of any composition, right? In the left it can be any volume, it can be volume, the shape can be, the container can be anyone. So thus take the corresponding volume of that particular container, right? Similarly, if you are emptied it into a different shape, or a container with having a different shape, just remember the formula, what is the volume of that container. Okay, if this cone, it is 1 by 3 pi r square h. So in place of pi r square h, we should have put up over here 1 by 3 pi r square h, right? Now, in which school you are teaching? No, I will discuss with you in details, Jay. It's not like that. Yeah. I will speak with you. Yeah. So just put up these values and get your answers. Okay. So Jay, nice interacting. You are such a nice person, and I will not your expectation from me to for physics. I will definitely come up, and please be assured. I will definitely try to explain all the details in topic to you, so that that topic, at least that topic which I will teach to you, don't worry, which I will try to, it's not kind of teaching from one side, it's an collaborative approach. Okay, if I am explaining the things and if you are interacting with me continuously and understanding the things, then definitely nothing is impossible. Okay, you are such a nice and you are such a nice person, right? And you are putting such efforts to and pushing me for putting up the physics sorts and physics explanation and live session. I will definitely come up, Jay. It's a commitment. सर मुझे ग्रेविटेशन चैप्टर पर दिक्कत है. ओह, what is the problem? Okay, but if we will discuss over here, then it can be uh, just I am getting one concept, just try to explain one concept of gravitation. Whenever there are two bodies, any two bodies in this space or atmosphere or universe, when they are kept in, when they are kept at a distance of r with each other, then there will be a force which is exerted by both the masses on each other, whose magnitude is equal to z m1 m2 by r square, right? This is the calculation in gravitation. Okay, no worries, it's not like that simple. You can, yeah, no calculation mistakes, it's not like that. You can do it properly, there should not be any mistake. Okay, but yes, you will have a proper understanding. I will definitely come up with the physics session into the next class. Okay, and I hope you like the session, right? And thank you so much for watching. So let me come up with the distance and displacement live session next day, right? And happy learning. No, आप जो लिख रहे हैं सर मुझे जो ग्रेविटेशन चैप्टर पर दिक्कत है, बी एश्योर्ड ये दिक्कत नहीं रहेगी आपको, ठीक है? देयर विल बी नो सच प्रॉब्लम इन ग्रेविटेशन चैप्टर. I will come up with the physics live session also, don't worry. हाँ जी जय, right? So I think in this question, any doubt which you are facing, or in understanding how to solve such questions, this is not just one question. How to solve all such questions where the volume or the shape could be anyone in place of a hemisphere. It can be cylinder, conical flask, a sphere. No sir. Oh great, so you understood the concept, very nice. So I will request you Jay and other my dear students, I will request you all to solve all such questions from your NCRT, from your all reference books. Even you can take some questions from YouTube and Google also, right? And just solve all such questions. If there is any query, just come to me and drop me a message, I will help you. Okay, but I want to make sure that if such types of questions are coming in front of you in your examination, in your competition, or any time in your future in front of you, then this should not be left unsolved. Okay, R.S. Agarwal is, yeah, it's a good book. No, there is no definition for best, Jay. Even I am good. Even I can say that in myself, in my words, I am the best. But this is not the correct word, because anybody can be even better than me. So yeah, we can say that R.S. Agarwal is a better book, good book, but best book, best book, that means you are keeping a cap, that means limit, that nothing best or nothing more can be improved after that. Okay, that is a good book and I love that book. It's not like that you are getting the harder questions in R.S. Agarwal. Okay. But if you are facing it, it's definitely the matter of practice only, Jay. Okay. You do a lot of practice, you will have a more understanding, and then you will be more confident upon that topic. Yes, and this will be no longer a harder. You will not feel hard. Be assured, I am multiple times I am assuring you. You can just try to solve such all questions. Okay, what I am showing you, you solve all such questions. And if you are getting any doubt, you can put up into the comment box. I will help you, Jay. Your biology, sir, my biology and chemistry concept are clear of class 9. Great, that's a very good news for me. Okay, and I like it. Okay, Jay, I think it's time to close this session. You are focusing only on physics. Okay, I will try my best to help you out, Jay. Don't worry. Love to be here. Bye. Thank you so much. Let me come up with the distance and displacement topic into the next live session. Okay, definitely it will be of physics. Nice to meet. Nice to meet you, Jay. Same here. Thank you so much for watching. Bye bye. Take care, and just concentrate on your studies. Nothing will be hard to you. Maybe in a day or two, right? Maybe tomorrow or day after tomorrow. Let me see whenever I am getting time. I will try to get it closed as soon, right? The timing will be definitely in the evening only. Yes. Thank you. Thank you, Jay. Thank you all. Thank you for watching. Bye bye. And good night to you all. See you.